Thanks again, Brandy. We're back here with Amy Ross, spacesuit engineer, once again at the Anthropometry and Biomechanics facility. It's a very NASA term, but they do some cool stuff in here with these advanced spacesuits. Amy, talk once again about what we're looking at back here.
So this is a Z1 prototype spacesuit.
Okay. And
we're going to use this spacesuit as a test bed, and then we'll pick a configuration that we hopefully will end up flying on a DTO, on the ISS, or some other kind of flight.
So let's back up and talk about the history. You know, if you look at the history of NASA, what NASA's done, there actually haven't been that many type of spacesuits. You had the Gemini spacesuit that Ed White used. You had the Apollo suit that went to the moon. And you've had the one that we've used for shuttle and station for over 30 years now. And this is the first time in decades that we've actually redesigned and tried to figure out, you know, what does this thing need to do on our future missions, right?
Yes. And of those suits, really, the only suit that was designed for one purpose, extravehicular activity, EVA, was the shuttle EMU suit for microgravity EVA.
Yeah.
And this suit is also an EVA-specific suit, but we're trying to design both to accommodate improved microgravity EVA capability as well as surface capability.
So that means basically that, you know, the suit that we've known for a long time is designed to float in space, build a space station, get outside. It's not designed to go walk on a planet,
no,
right?
It's a very, very poor walking suit.
Okay, so
this suit is designed with some very good walking capability built into it.
What are the main differences? Like, what is this suit going to do that hasn't been done in so many years? I mean, is it the legs? Is it the show it off a little bit.
We have a waist bearing here.
Okay.
So if you ever walk around with your hand on your belt buckle, you'll realize how much your waist moves back and forth as you try to walk. So this is a very enabling walking feature in this suit. We also have bearings in the suit here at the hip and the upper leg, which again allow you to walk. Right. And we'll see our subject do some of that. And I believe we have an ankle bearing on the suit as well. And that allows for fine foot placement as you're walking over rough terrain.
Now, is this new? Is this new based on, you know, what the suit is right now, or
some of the patterning of the soft goods between the bearings is new.
Okay.
The specific placement of the bearings is a little different, and then the shoulder is a new shoulder design.
And this is based on what you've learned throughout the entire shuttle station programs and what's worked, what hasn't worked,
and we've had a couple of advanced prototypes in the past that we've also tested significantly and then tried to put some of that lessons learned into this suit. And then we'll again test this suit. And so we'll look at all the data from all the prototypes that we've had, and we'll pick the new configuration that hopefully does what we expect it to do and perform well in microgravity and planetary.
So, I mean, the main difference to me, as somebody who is not an engineer, obviously, is that the top of this looks radically different than what we've seen in the past.
Yeah, so one of the big differences is the rear entry design.
Okay.
So the shuttle EMU splits at the waist.
Right here.
You put pants on, and you put the top on separately and then connect in the middle. Whereas in this suit, the subject crawls in through the back, and then we just shut the door, the hatch.
What are the benefits of that? Is it easier to get on and off? Or?
Yeah, we think it's less prone to injury, especially shoulder injury, which can occur with the shuttle EMU donning method. And then also it provides support for some other exploration technologies like a suit port that might be a good
That's what people have seen on the rover, right? So these, you know, you've seen the concept of these suits basically mounted to the outside. They would crawl in, and you don't have to go through an airlock or anything. You just crawl in and step off and go. So this really represents what you've learned throughout shuttle and station, and also the testing you've done out in the desert, right?
Yes.
Talk a little bit about what you guys have done over the last few years out there.
So I've participated in the second, we called it Desert Rats analog. That name actually came later. We just did spacesuit field testing at the beginning. And so we wanted to understand how a suit that we wanted to build for the moon or Mars would be at doing its job. And the only way to do that really is to go out and see. So have a subject in the suit do geology and see how well the suit allows them or doesn't allow them to do that job, so you know what features you need to focus on for forward development.
Talk about the weight, because I don't think people understand exactly how heavy these suits are. I mean, they're several hundred pounds that the astronomy, obviously up in, you know, they're up in space, they're not weighing them down, but here on Earth, they're pretty heavy, right?
Yeah, this suit with all of its complement, including the suit port plate, is 158 pounds. Yeah. So it's a heavy suit. Yeah. We have the Mark III prototype in the lab, and that weighs right around 100 pounds. So it sounds very heavy, but when you inflate the suit, it does help to support itself. But the difference between this suit and the Mark III is significant, and we are seeing that in the workload of the subject. So they're able to do it bear the weight, move around very well, but weight does still matter.
Yeah.
Even if you're going to Mars where it's 1/3 gravity.
So last question during this segment, you talked a little bit about having to design this suit to not only go up to microgravity, which is what you see on station. They're out there floating around, they're not walking on anything. So our future missions obviously are going to be to an asteroid and then later on to Mars. So you're saying that you're basically designing this suit to kind of tackle both of those, even though those are radically different missions,
the strategy
right?
we're taking right now is trying to look at all of our requirements on all the potential destinations and try to understand what the most challenging of any aspect is. Like for mobility, it's probably walking on a surface.
Yeah.
For radiation protection, it's deep space. So you look at each aspect of the suit design and you try to pick the most challenging and you try to design so that you're capable for that. And then when you need to just specialize for one specific mission, you already have that information and capability to build the suit that's going to work for that mission.
Well, it's been a while since we've walked on a planetary body. So do you go back and do you take a look at what Apollo, the lessons learned? I mean, it was only a few flights, but
yes.
They learned a lot about those suits just from the astronauts being up there walking around.
So
right?
we've read through all of the debrief comments. We've talked to the crew members multiple times. So we are very aware of what they did like, didn't like, were capable of, weren't capable of. And so we do take that in consideration. And then we work with the current crew and help to get comments from them to understand that we're addressing the concerns of our current customer base.